Hi, this is Raina Fitzgerald with Manchester Community College, and we're continuing in our Probability and Statistics course, and this is week 2. In this week, we're going to be looking at characteristics of data. In the characteristics of data, we want to pay attention to the center, and oftentimes that's the mean, how the data varies, so that's the variation, what the distribution looks like, and outliers. Outliers are values that fall outside where the rest of the data sort of centers. Like it's sort of way outside. We call those outliers. And we're going to do this by examining frequency tables. When working with large data sets, it's often helpful to organize and summarize the data by constructing a frequency distribution table. The frequency distribution table helps us understand the nature of the distribution of a data set. And we're going to start by looking at a set of values. These are pulse rates for females in beats per minute. And we're going to create a distribution table from this data. Now we have a set of data, and this set contains 40 values. So we say n, which is the number of elements in our set, is equal to 40. So we have 40 values, which means we tested 40 subjects, or someone tested 40 subjects, and here we have their beats per minute. And so we want to analyze this data by creating a frequency table. So the first thing you do is we're going to subdivide this data into different classes. Now, when you're selecting classes, you have to decide how many classes you're going to have. And generally, you want to have between 5 and 20 classes. In this case, let's select 7. 7 will be our number, 7 classes. So we're going to have 7 classes in our distribution table. Now, we have to next decide what will our class width be. So to determine the class width, what we want to do is we want to take a ratio of our largest data value, minus our smallest data value, and divided by the number of classes. So in this case, we have 7 classes, okay? So let's take this calculation that we're doing. I'm going to move it down. It'll disappear for a minute. While I move it down, I'm going to put it underneath frequency distribution table. Okay, so our largest class size, well, let's take a look. I'm going to circle the largest class size in red. The largest class size, let me comb through this data. Looks like 124. So there we go, 124. And our smallest class size, right here, 60. So to find the width of our distribution table, we want to take 124 and subtract 60, and we're going to divide that by 7. And if we do this calculation, we should get, about 9.14. It's a repeating decimal. I'm going to move this over, give us a little room, because I'm going to estimate this, or approximate it, I should say. Let's approximate this to be 10. So we're going to have a class width of 10. Now, let me go ahead. I'm going to shrink this down so we can create the distribution table on this page. So hold on. It disappears for a minute while I resize it. And I'm going to make it a little bit smaller so I can fit it up above right there. And there you hear. See, class width is equal to the ratio of the difference between the largest and the smallest value divided by the number of classes. So we have a class width, and let's highlight that, a class width of 10 beats per minute, 40 values, and 7 classes. Okay, so we're going to start by creating our first class. Well, our first class is going to start with the lowest level. So the lowest level is, well, we need 7. We need 7 levels. So what I'm going to do is let's set this up. I know I need 7. So 7 class levels, 2, 3, 4, creating my lines, 5, 6, I need one more line, we'll put it up here, 7, and then we'll just move it down. There we go. Okay, so our smallest class width, well, it's going to start with the smallest data. It's going to go from 60, oops, let me fix that. So I'm going to zoom in on this a little bit. Our smallest class, I'm going to start in the lower left-hand corner, is going to go from 60 up to another value. Now, what I want to do here is I'm going to find all of the class widths. There are 7 of them. And I want the lowest number for each class width, okay? So for each class, I need the starting lowest level. And since our width is 10, then our next lowest level is going to be 60 plus 10, so it will be 70. And our next lowest level will be 70 plus 10, which is 80. And our next lowest level is 80 plus 10, which is 90. And you can see where I'm going here. The next one would be 100. And then we have 110. And then our very last class will start at 120 beats per minute. Okay, now our class each class represents all the values that have a number of, all the data values that have a specific number of beats, and they have to fall into the range of that class. Now, if we're going to start if our first class, put a 1 here, if our first class starts at 60 and our second class starts at 70, and the first class is going to go from 60 to 69 beats. And of course, because our third class starts at 80, our second class will go 70 to 79 beats. And then it continues. You can see where I'm going. This one would go 90 to 99 beats. And our fifth class is 100 to 109 beats. And our sixth class, remember there are 7 classes, goes 110 to 119 beats. And then our 7th class is 120 to 129 beats. And we know that the largest value is, let's see, that was 124, so that's going to fit in there. Oops, I lost the 89. Let's zoom back there. Okay, I lost the 89. All right, now what we want to do is we want to put tick marks in. We're going to go through our data, one data value at a time, and put a tick mark in the class in which it would reside, okay? So the first one is 76. I'm going to maybe make my font, well, we'll keep it the same size. Okay, our first value is 76. So I'm going to put a line through 76, and 76 falls in class 2. And I'll put a line through 72, and 72 also falls in class 2. And then we have 88. Well, 88 falls in class 3 because it's between 80 and 89. Here's the 60, that's the smallest value. That, of course, falls in class 1. Then we have a 72. 72 falls in class 2. And a 68, that falls in class 1. You can see what I'm doing here. There's 80. 80, and this takes a little while. We do have software that does this, but it's important that you understand how to create these. And so as I'm going through these, you can see there's 268, so I have to put 2 tick marks. 1. Now this is a 5th tick mark, so I slash it across like that, and in class 1 I have 5 data values. Here's an 80, that goes here, and a 76 here, and a 68. That goes in class 1. We have a 72, and that's going to bring us up to 5 in class 2. A 96, that's class 4. 72, we're back to class 2. A 68, class 1. A 72 is class 2. And I'm just going to keep going. You can see what I'm doing here, and this should take me just a bit more time. I'm getting close. We're half done with the data. Let's finish this off. There's an 80. And 80 goes in class 3. 1, 2, 3 76s, that's class 2. 1, 2, 3. That brings us to 10 in class 2. Here's an 80. A 104, that takes us up to class 5. An 88. class 3. And a 60 brings us back down to class 1. So 10 values in class 1. 76, 72, 72. 1, 2, 3. They all belong in class 2. 1, 2, 3. 88 and 80, that's 2 values that belong in class 3. 1, 2. Then we have a 60, that's class 1. A 72, that's class 2. 1, 288s. 1, 288s. A 124. That almost seems like an outlier. And a 64. And that's down here. Okay, now what we do is we add them up, and let me take a different color, and we're going to take their totals. So let's see. In level, I'm actually going to draw a line here. I'm going to draw a blue line here. And I'm going to write the sum of the number of the data values that belong in each class. In class 1, we have 5, 10, we have 12 values in class 1. In class 2, we have 14 values. In class 3, we have 11 values. In class 4, we have 1 value. Class 5, 1 value. We have no values in class 6 and 1 in class 7. And this is how we create a distribution table. I'm going to move this over. We did our calculations also here. So I'm going to move it over and show you that the distribution table actually doesn't need to have the tick marks in there. Those tick marks were just, would it help us out? Oops, let me fix this. Oh, it popped back. Let me bring that back. Back. No, okay. Let me erase these extra lines. Okay. And I'm going to move it over to the left again. Move it over to the left. Okay. Now the frequency distribution table usually would just consist of our classes. So I'm going to grab the classes and let me copy those. But just the classes without the tick marks over here to the right. There they are. And then it would also consist of the, let's see, and then it would put a line down the side. Now this over here to the right is really what our frequency table would look like. Where the table to the left, it is a frequency table, but it contains all the tick marks, and you actually don't need the tick marks in the actual table. You just need the frequency with which the data occurs. Okay, so this is our distribution table, and what I'm going to do is, let's put a box around it, because we just finished our distribution table. Here it is. And this is the distribution table representing the data for the pulse rate of females. Now, what we're going to do is we're going to take a look at another kind of distribution table that allows us to analyze our data. And in this case, this one is called a relative frequency distribution table. So what I'm going to do is I'm going to grab the distribution table. So now we know how to create a distribution table. And that's this blue table that I boxed in blue, which is over to our right, lower right. And I'm going to copy it. It disappears while I copy it. I'm going to copy it. And it's going to put it right back. Okay, now I'm going to go to the next slide, and on the next slide we have a relative frequency distribution table. Now this one's a little bit different, so I'm putting back our frequency table that we just created, and so to the left we have basically just a regular frequency distribution table, which is quite helpful information there, and now we're going to create a relative frequency distribution table. And a relative frequency distribution table is a little bit different, and so let me copy this, and it looks similar, but the right hand column has percentage instead. Let me copy this and paste it. Okay, so on our right hand side we're going to have, this is going to be our relative frequency distribution table down here, where the other one is just a frequency distribution table. And what we do is we are going to make a calculation. So for example, for our class 1, which is the bottom, we have a 12. That is 12 values out of a total of 40 values. And if you put that into the calculator, 12 over 40, let's go ahead and do that. Let's I'm going to put that into my calculator right now. 12 divided by 40 gives us 0.3. 0.3. And, or that is actually 3 out of 10. So this reduces to 3 over 10. Okay. And so fussy. It's 0.3, which is equivalent to 30%. And so we're going to replace this. Now we have to change the value that we have in our, because this is, we need to change these values, because this is, right-hand one is a relative frequency distribution table. So it's, we want instead to go inside the relative frequency distribution table is the percent of values that occur in that class. And right here, 30% of our values reside in our very first class. Now let's move over to the next one, and here we have 14. So this one here is going to be 14 values over 40, and you can simply put that into your calculator because we could reduce it to ourselves, but 14 divided by 40, and that gives us 0.35, and 0.35 is 35%. That's 35%. So more data values exist in our second class. Okay, so this is 35%. And now let's keep working our way up. Now we have 11 values here in class 3. We have 11 values out of 40. And if we put that into our calculator, 11 divided by 40 gives us 0.275. 0.275. And percentage-wise, now remember with percent, you have to move that decimal place over twice. So that's 27.5%. So that's class 3. So I'm moving over to class 3 and putting in 27.5%. Now the last classes have a much smaller percentage. As a matter of fact, let's jump right up and let's go right up to the last class, class 7, because that's sort of reoccurring, right? Class 7 is 1 out of 40. And the decimal value of 1 divided by 40 is 0.025. And remember, we have to move the decimal place over 2 times. So that is going to give us 2.5%. And that 2.5%, well, that 2.5, no, fix that a little bit. It's hard to read. 2.5% is also the values for these two classes here, right? And then, of course, this 6th class is 0%. So let's go ahead and put those in here. 0.25%. Change to blue. I'm sorry. It's 2.5%. So this is 2.5%. And I'm going to kind of copy this and paste it. Oops, I went a little too far. So I'm going to copy that. And also we have 2.5% down here. And let's see, it is actually the 6th class that's 0%. So I'm going to go back over here, and we have another 2.5% here, and then a 0% in our 6th class. And here we have it. This is our relative frequency distribution table. So it represents all 7 classes from 60 to 69 all the way up to 120 to 29 heartbeats per minute. And it tells you what percent of the data falls in that value. And you can see the majority of the data actually falls in the first 3 classes. And in fact, the last 4 classes hold a very small amount of the data. Okay? Now, the next thing we're going to look at is a cumulative distribution table. That's another way of looking at your data. So for a cumulative distribution table, we have to go back to the original frequency distribution table, which we have right here on the left. I'm going to grab that, minus our calculations. Let me copy it. And let's go back to this page, or to this page, forward to this page. And here I have on the left-hand side for my guidance that this is my frequency distribution table, and I'm going to use it to create a cumulative frequency distribution table. And in a cumulative, well, these values are different. And we start from the first class, which is our class 1, which is at the bottom. And what we do is we write, first of all, class 1, actually, we write the number of values. So I can put that back, 12. But for class 2, we're going to take the 12 and add it to the 14. So in class 2, we're not talking about how many values occurred in class 2, but how many values occurred in class 2 and all classes before it, okay? So that would be 26 values. So from class 2 down, 26 values. And so then we want to find out in class 3, right? This is class 1, class 2. I should probably put these numbers back. We don't usually number the classes like this in a frequency table, but it helps us to reference them as I talk about them. So for class 3, we're going to take 11 values in class 3, plus a total of 26 values before class 3. And if we add those up, we get 37 values. 37 values. Now in class 4, we have 37 values plus the one that's in class 4. So by the time we get to class 4 and through class 4, we've gone through a total of 38 values. And you can see in class 5, we add one more value up to 39. No values in class 6, so 39 values from class 6 down. And then class 7, 40 values total. So this is what we call a cumulative frequency distribution table. Okay, so we've got 3 different kinds of distribution tables that we've looked at so far. We started with our frequency distribution table that we have on this page, and let's highlight it. This is our frequency distribution table, so I'm highlighting it. So if we wanted, this is how we would create one. We create our classes, and of course we started by finding the starting point, the largest value, the smallest value, the number of values, deciding on 7 classes and calculating a class width. And on the next page, we found the relative frequency distribution table, and in this case, I'm going to highlight this one. In this case, instead of putting the number of values, we have the percent of values that occur in each class. And you can see that the majority of the values occur in the first 3 classes. And then in the most recent one we just did, we found the cumulative frequency distribution table. And this one gave us, for any class, it gave us not only the number of values that occur in that class, but all classes before it. Okay, so this is one of the things you do when you first start analyzing your data, is by looking at a frequency distribution table. And what we want to look, we're going to be looking at the center. Where's the center? We'll be trying to find out where's the center, how does it vary, how is it distributed, are there any outliers? That's what we're doing. And I can see by looking at my relative frequency distribution table that it does look like there might maybe be an outlier right here. I'm thinking maybe this doesn't really belong. Is that an outlier? Might be. The data does, though, seem to be clustered around class 1, 2, and 3 down there. Now, one of the things as we move forward in this week, we're going to be looking at analyzing the data, And we'll be looking at a normal distribution. And a normal distribution, the frequency starts low. Okay, let's think about this. In a normal distribution, the frequency starts low and then increases to one or two high frequencies and then decreases to a low frequency. Let's diagram what this might look like. Oh, it would actually, we'd have classes, right? So we'd have to set up a similar type of thing where we have classes and we'd be putting our tick marks in, trying to have, we just pick our whatever classes that we're going to have, and we put our tick marks in, and as we put in this tick marks, we'd be putting them in as they grow, and we'd find them growing and growing more towards the center and fewer towards the outside. So we'd sort of be adding them and finding more growth in the center, not as much on the ends. It means looking sort of like this. And let's see, if I'm growing this, I better grow these more. And it starts to look what we call bell-shaped. This is sort of normal. You think of like the shape of a bell shaped. Oops, let me turn off my straightener. So it looks normal. This is sort of giving you an idea of what we're talking about. When we talk about normal, we say that it's shaped like a bell curve. So let me say that again. The frequency starts low, as in not a lot of tick marks, not frequent that data would occur in the lower or upper classes. Then it increases to one or two high frequencies. And here I have, these are my high frequencies here. Okay, so this would be sort of, it would be the center would be somewhere in the middle here. Okay, and between the two high frequencies. And then it would decrease to a low frequency. Normal distributions are approximately symmetric, with frequencies preceding the maximum being roughly a mirror image of those that follow. So it should be a mirror image across the center, okay? Symmetrical. And so we're going to be looking at normal distributions. So this concludes our first lesson for week 2 on frequency distributions.